Hello, my name is Sayed Tabatabaei, and this is my presentation for Physics 2212 Lab 1 report, which is about charged tapes and their interactions towards each other. Okay, this lab's ultimate goal is for us to approximate how much excess charge we have on a single piece of tape. We will be making isolated charges on those tapes, and we will also be determining the type of electric charge present on the surface of the U-tape. We will be using Newton's second law, electric field and electric force laws to determine the amount of charge present on the tape. We will also be using glow script at the end to demonstrate how the forces are acting on the tape and compare their magnitudes to each other. The main concept that we're going to be using in this experiment is Newton's second law, which states F equals ma. And in the case of our experiment, we can apply that law to the gravitational force, which states F equals mg in the direction of the gravitational force. We also have to keep in mind the laws of electrical fields, their formulas, and in addition to that, we have to remember that like charges repel each other, opposite charges attract, and any charged object attracts a neutral object. For the procedure of this experiment, I began by laying down a 20 centimeter piece of tape on the table, which acts as our base tape, and then I made another 20 centimeter U-shaped tape and laid it flat on the other piece of tape. After that, I ripped off the U-shaped tape quickly and attached it to the side of a table. First thing I did, I held my hand close to it and I saw that the tape was getting attracted to my hand, which is a neutral object. Then I made a negatively charged pen by rubbing it with a piece of cotton and held it close to the charged U-tape pen. And my observation was that the pen and the tape also attracted each other, which concludes that the tape is positively charged. For the second part of the experiment, I made two U-tapes and tried to make one float using the other one. And at last I measured the distance between the tapes at the moment that the upper U-tape started floating, which means we're at the equilibrium point. To simplify the calculations of this experiment, we have to make certain assumptions about it. We have to assume that Coulomb's law applies in the case of our experiment. We gotta assume that the charges are equally distributed over the surface in the first experiment, and then in the second experiment we have to assume that the total charge acts as a point charge in the middle of the tape. For equilibrium conditions, we have to assume that gravity and the electrical force from the first tape are the only two forces acting upon the top tape. We also have to assume that each tape has the same net charge. Here's a list of observations that I made during the experiment. The length of the piece of tape was 0.2 meters. The width of it was 0.019 meters. The conversion factor is 0.00 kilogram to meters. And the distance between the flowing tapes at the moment that it started flowing was 0.060 meters. I also observed that the tape gets attracted by the pen and tapes repel each other. For my calculations, I started with calculating the mass of the piece of tape. Then I used that data to calculate the gravitational force acting upon the tape and the direction of it. And using my Newton's second law, I can tell that the gravitational force and the electrical force are the only forces acting upon the tape, and therefore they're equal and opposite in signs. After that, I proceeded with reordering the formula for electrical force to obtain the electrical charge present on the tape using the distance I measured during the experiment. The force came out to be 7.47 times 10 to the negative 9 coulombs. Then I proceeded with the calculation for the amount of deficient electrons, which I divided the whole charge by the charge of an electron. And then after that, I calculated the ratio of electron to atoms, which came out to be 1.22 times 10 to the negative 7. And this is the code for my GlowScript program. The first part is mainly the constants that are going to be used in this experiment. The second part, I basically calculated the point charges. Third part was for the distance. The fourth part, which was the most complicated part, was for the calculating the gravitational force. And then I basically graphed it, and based on the graph, you can see that the electrical force, which is the green arrow, is pointing up. The yellow is the gravitational force pointing down, which cannot be seen quite completely. We can also see that the numbers from the program uh, are the same as the numbers that I calculated from my own calculations. What will happen if electrons had a positive charge? If electrons had a positive charge, then the pen would also be positively charged. We previously concluded that the tape was positively charged. Therefore, in the case of the partial lack of electron on the tape, the pen would still attract the tape. Overall, nothing would change. Why is it important to handle the charged tapes as little as possible? Because a charged object either has a deficiency of electrons or an excess of electrons. Contact would cause a discharge or a gain of charge on the object. And this was my presentation for the first lab. I hope y'all enjoyed it. Thank you and have a good day.